Well, hello everyone, and welcome to today's webinar. My name is Gino Sigismondi. I'm Associate Director of Technical Support and Training here at Shure. Joining me today are Chris Neben from our Market Development Team and Rob Klegon, Product Manager here at Shure, and we're going to be talking about microphone selection and placement for conference rooms. We've been doing a whole series of microphone selection and placement webinars recently on different topics because depending on your application, you may have different needs, and the conference room provide some unique challenges that may be different from some other applications. So we've got two experts here today to talk us through this. But before we get there, just a couple items to keep in mind. Number one, we will be taking your questions at the end of the webinar. Feel free to ask them at any time via the questions pane. So if you are looking in the GoToWebinar control panel, which is usually off to the right side of your screen, there's a little place for you to type your questions in there. So feel free to enter those in there at any time, but just know that we will answer questions at the end of the webinar. If you don't see that questions pane, look for a little orange arrow on the right-hand side of your screen, and you can click on that orange arrow and it will expand the control panel so you can see that questions pane and then hide it again if it is in your way. And the second thing that you would want to know about is that this webinar is being recorded and will be posted on our website. It usually takes about a week, but if you go to www.shure.com/training, in about a week, the webinar will be posted there, along with all of our other webinars on a variety of useful topics there. So with that in mind, I say we get right into it. So I'm going to go ahead and pass things over to Chris to get us started. Chris?
Howdy. Yeah. We'll get this thing going here. So a lot of times we get asked about placing microphones, which one's the best one for conference rooms and such. And while this is very important, picking the right one, not only form and function really, but there's some other things that we thought would be good to discuss beforehand, which include acoustics. Acoustics play a major role in how your conference audio plays out. So with that, we're going to touch base on those things, what to watch out for, and hints on how to improve conference room acoustics. Of course, talk about the function of a microphone, in other words, its intended use, polar patterns to be reviewed, the actual user interface side of things. Also, the form of the microphone. Hopefully this actually follows function. But the different forms of the microphone, of course, can include things like being wired or wireless, or maybe even not visible. That's a good one. We'll get there towards the end here. But moving along here, this acoustics thing, why in the heck does it matter? Well, as you see here in the graphic, speech tends to become attenuated over distance. And at some point, it actually falls off into the noise and reverberation. That distance at which the noise starts to become part of that noise floor or that reverberation space is called critical distance. If your microphone is beyond that point, the noise and reverberation is so high, or the ambient sound of the room is so high that the voice is now part of that noise, there is no microphone, at least not today, on the face of the planet that can differentiate between a human voice and the rest of the noise that's happening in the room. So that direct sound from the talker, capturing that direct sound well above the noise floor is really critical. Well, what causes that noise? In most cases, HVAC, which is your heating, ventilation, air conditioning, that's usually the biggest offending thing in the room. The ducts themselves can whiz and whoosh, create hissing sounds. The vents also, really, this is where a lot of it happens too. The sound of the air passing through that vent creates some kind of a noise. You want to keep that stuff sized appropriately. We'll talk about NC ratings in just a moment here, but there's a way to pick the correct vents and ducts to make this not be a problem acoustically in your space. Another thing here, mechanical issues, right? If you got fans or chillers or pumps or dampers or anything like that, certainly if they're nearby, you got to keep those isolated from that room. There's no need to to transmit that audio through your conference. So if you can even keep those rooms completely separated, maybe on the other end of the building from where your conference room is, and in other words, really, this is usually a factor that goes the other way around. Mechanical devices such as these pumps and dampers kind of need to be in a certain place. So don't pick the space right next to it to put your boardroom. Put it in a different place for the conference room. And then, of course, outdoor or environmental noises can affect the conference audio. Many times we see these really awesome conference rooms with a great view looking at something, the mountains in the background or the ocean or whatever it might be. Yet there's some major thoroughfare where traffic, horns honking, blaring, or just the roar of traffic moving itself is transmitted through the glass into the room. These can be major negative impact factors on your conference audio. So I had mentioned noise curves or NC ratings here. This is really a common way to measure for background noise in an unoccupied space. And this terminology is used by all of the professionals. So the idea is that you can produce a single value representation of the complete sound spectrum. And while there's various different methods used to do this, the one we're going to focus on and talk about today is NC, or noise criteria rating. This is what these things look like. You can see the graph here on the left. There are several different segments here. We've got from the left to the right on that graphic is the actual frequency. So 63 hertz all the way up to 8,000 hertz. And then up the left-hand side is 0 dB to 90 dB. And the graph shows at the very top, for instance, an NC rating of 70. This would be a very noisy, high ambient noise floor room. The other side of that, all the way at the bottom, is an NC 15 rating, and that would be a very quiet room. So think of things like an IMAX theater. These are spaces that tend to have that specification or requirement that the noise criteria must not exceed 15 or 20. Notice that these are increments of 5. And each of these are defined by the lowest curve that's not exceeded by the measured spectrum at any point in the audio frequency range. So again, even if a room had buildup at 250 hertz, but the rest of it was lower, that buildup at 250 hertz would pop it into the next noise criteria rating. We recommend an NC rating of somewhere around 30 or below for conference rooms. This seems to be pretty typical. This provides for better acoustic environment because we've got less ambient noise. So back to that HVAC section, the actual registers and return grills are rated. And on the low side, again, NC 15 to NC 20, you can get an air supply register that's rated at an NC 15. This means that it's only moving 250 to 300 feet per minute of air. That's the air velocity. The grill on the other side is 300 to 360. And then a higher NC rating room, so NC 40 to NC 45, that supply register is moving as much as 650 feet per minute. This is, again, the air velocity. So you're going to start hearing more of that noise, more of the air sound moving through that vent, through that register. So back to this idea, we want to isolate any of this equipment that moves. Certainly, if you can see it, you can probably hear it. So get it out of the way, isolate it. Select different diffusers for that HVAC system. Want to give a quick shout out here to Avant Acoustics. They actually posted a blog on this very thing just end of last week that dovetailed nicely into this talk. So this is almost point for point their blog here on things to be cautious of for acoustics in the conference environment. So let's see here, moving along. Also must seal the gap. So anywhere there can be air that moves through a gap, audio can move through there as well. So things like doors and windows and other penetrations, maybe where walls meet each other, the floor and the ceiling. If air can get through there, so can sound. So make sure all the gaps are sealed. Having a massive building envelope. This is really a multi-layered wall or roofs and windows. All of this with the idea that you're isolating the inside of your building from exterior noise sources. So unless you enjoy the roar of traffic coming into your corporate room, your conference room, think about doing this multi-layered walls, roofs, windows, all this stuff to really have good isolation from that outdoor exterior noise. Sorry, jumped ahead too quick. Also build the walls to the deck. So what this refers to is many conference spaces have drop tile ceiling, or maybe there's a void to the ceiling above, even if there's not drop tile. But what happens is in the larger floor space, if all of the ceiling space above is open, potentially we have another space where audio or ambient noise can play into and get transferred into other rooms. So if we build the walls in those rooms all the way to the deck, this helps to stop unwanted sound from penetrating into other rooms around that one room. Also, you want to put batten insulation in the stud cavities of any any partition separating two occupied spaces. So this is the easiest way to improve performance of the partition itself. Sometimes folks, you might have experience with this, like for instance with air walls that come in for dividing up spaces. If those walls don't have enough absorption or batten in between them, it's as good as just another big transducer that's allowing sound to transmit into other spaces. This is another big one, avoiding concave shapes. If you've ever been to any type of a space that has these concave spaces, these shapes, this circular round, these domes, barrel vaults, etc., etc., someone on the other side of the room could whisper, and you can hear it just because of the way that audio gets transmitted and bounced off of these. In other words, this very reflective space. So avoiding these types of shapes is really good and important too, keeping your acoustics in check. Choose hard and soft surfaces appropriately. Of course, this is not always up to us lowly AV folks, but we certainly can recommend it. A lot of these boardrooms these days have 3 glass walls. 3 of the 4 walls are glass, very reflective. And then the other surface is got some kind of a large display on it or something. Ideally, you're putting as much as 50% absorption or covering on your walls to help absorb any kind of acoustic sound that's bouncing around. So this is important here. Finally, probably the most important one of all is check in with somebody who's qualified. Get someone who knows what they're doing, especially if this is a challenging room and you're walking into it. It might be smart to have somebody join in like an acoustical consultant that can make your case for you. There's really no fixing a bad acoustical room with any microphone. So these are things to think about. What's interesting, though, is that, while we complain about boardrooms today, and all the hard surfaces and all this kind of thing, it's something that's been around for quite a while. And this is a little section that comes out of a Bell Systems Voice Communications technical reference. This is from 1977. This reference was specific about acoustics of teleconference rooms and guidelines for group audio teleconference systems. By the way, if you wanted to read this whole document, it's available on our website. Go to Shure.com. Go to Find an Answer, and you can search for FAQ number 3835. You see that there. But anyway, this kind of really illustrates still our challenges today. Unlike telephony between handsets, the acoustic properties of the conference room and the placement of microphones in the room critically determine the level, the speech signal to ambient noise ratio, or in other words, critical distance, and the reverberant quality of the transmitted speech. Particularly in multi-point conferences, these three factors are easily judged and critically commented upon by the users. So again, I think we've all been in the boat where we get that call and there's complaints about how the audio system sounds, but only to kind of be able to point back at a text like this saying, well, maybe we've got reverberant issues, maybe we've got ambient to noise ratio issues, single to ambient noise ratio issues. So typically, this thing sums up exactly what the problem is with any room. But knowing why acoustics matter, kind of getting a grip on what you can do to fix some of these problems or engage the smart people like our acoustical consultants to help with solutions. The other side of that is correctly choosing the proper microphone and placing it in the right place. This will also help for more intelligible audio. So, the biggest question we get, the exec comes in and says, I want broadcast quality audio. This is what we want for conference audio. And so we show him what that looks like. Here he is wearing his broadcast BRH 50 headset. And then, of course, they laugh and they go, well, we'd never do that. We couldn't have that for conference. Okay, well, how about something like this? This is nightly news, broadcast quality audio. Everybody gets wired up with a lavalier. Could be wired or wireless. Nah, we can't do that either. You say, well, maybe it's radio broadcast. So this is actually the setup I'm using right now. This is an SM7B on a nice long extension arm with headphones. And you go, that's broadcast quality audio. And they go, are you crazy? We're not going to do that on our table. Well, of course you're not. That's true. However, all of these options increase signal-to-noise ratio, right? This is our critical distance playing out over again. The microphones are close to the talkers. We've isolated headphone feeds for the most part. And acoustics aren't playing into this idea. So knowing that a close talker mic is best, especially based on critical distance, we can kind of move forward from here. Certainly ear-set microphones are a great possibility here as well. But most executive conference rooms are going to want to see something that is not a close talker microphone. And by the way, it becomes a compromise, right? The further the microphone becomes away from the talker, the more of this ambient noise issue we have in the room. Critical distance becomes a factor. So let's look at polar patterns. Many times we've been asked, well, just show us the best omnidirectional mic you can have because we want to pick up everybody all around the table. And so you might consider an omnidirectional microphone. This picks up 360 degrees all around, everything equal. The only challenge is that most of the rooms that we're putting microphones into these days do not support an omnidirectional microphone. If we had a noise criteria rating somewhere down around 15, we could probably get away with it. Wouldn't be too big a deal. But the reality is they're all up around 30, 40, 50, and we need something with more rejection to reject more of that ambient sound. So you could consider something like a cardioid style mic. And now if you notice the graphic on the right-hand side there, we're showing its pickup pattern is directly in front of the microphone. And the further you get off axis to one side or the other, 90 degrees, it starts to become attenuated all the way around to the rear of the microphone where there's the most attenuation at its 180 degrees off axis position. In a perfect world, you would point this thing towards the talker and the noisemaker, whatever that might be, the HVAC or the projector fan noise, would wind up in the null or in that 180 degree section of the microphone. You say, well, that's great, but I have a really high noise floor in my conference room, NC rating's high. We'll say, okay, well, we can continue this with polar patterns where we kind of get them tighter and tighter to have more and more ambient rejection. And you might want to note here, though, that on this supercardioid, where it became a little tighter, now there's starting to become a lobe off the back end of it. So still, there's a trade-off. Even though we're trying to tighten up this the pattern of this microphone, and this is the case for any supercardioid microphone, and the tighter that we go, you start to have this lobe that comes off the back of the mic. In fact, when you look at any of the microphone patterns available, from left to right here, we start with omnidirectional, mentioned that already, coverage at 360. Subcardioid, we start to have some rejection, so its angle of coverage is about 150 degrees. The cardioid is at about 131 degrees angle of coverage. Supercardioid's getting tighter, 115. Hypercardioid down to 105, all the way to a bidirectional microphone at 90 degrees. Now, something that's interesting about the bidirectional microphone that's particularly effective in conference rooms, even with harsh acoustic environments, is that you'll notice that it picks up equally at the 0 degree in front of the mic, so to speak, and then it picks up equally on the back end of the mic, 180 degrees on the other side. So that could be really effective for covering either side of a conference table, one or two people, depending upon distance, on each side. So again, I could have a person at the 0 degree mark, a person at the 180 degree mark, have one single output, not two microphones, but one single output to my processing in AAC, have great ambient rejection. Bidirectional microphones are good. But how do we put those into play? Let's talk about the form of the microphone now. We've talked some about how they function. Let's talk about the form. So these are the goosenecks, are something that I think most folks have seen before, and not necessarily any kind of a big issue for some folks. They can made to be wireless or wired. The nice thing about the one you're looking at there in the graphic is that that's actually the 10-inch version. We do offer these in a 5-inch, a 10-inch, and a 15-inch. But you can see there with the one that is the 10-inch version, it's usually just enough to peek over the top of laptops. So the advantage to a gooseneck, it's still relatively close to the talker. It's not quite as far away. However, sometimes folks don't like the way these look necessarily. They can be, by the way, you'll see these with green LED rings around the bottom there. That's another benefit to these, is you can show mute status on the device itself, so folks know when they're hot and when they're not. But when you need something even lower profile, you might wind up with something like a boundary microphone. Arguably, a boundary microphone might sound a little better acoustically. If there was nothing else in the room, no other devices or anything sitting in front of these things, they actually sound pretty darn good because there's no indirect reflection coming into the microphone. So I'll skip back one here on the gooseneck. You can imagine if somebody's talking, there would be direct sight of that person talking right off of the microphone element, but there could be reflected sound off the table or off that screen coming into the microphone that might cause a hollow type of sound. This is what we call acoustic comb filtering. With a boundary mic, we don't really have that issue. There's no early direct reflections there. Now, there could be later reflections, but really the bigger challenge with boundary mics that some folks complain about is that, well, they're kind of invisible. They're kind of on the table and nobody knows maybe what they are, and they'll come in and they'll throw their books over the top of it, or they might tap their pen on it, not realizing that that's an actual microphone, which of course this causes all kinds of problems for the far end listening to that audio. So arguably boundaries could sound better, but again, they have certain challenges just within their own right. Pushing the bounds of technology when it comes to boundaries, the MXA310 is a newer microphone for us. It's been shipping about 2 years now, I think. The 310 is quite unique when it comes to a boundary microphone. Previous to the 310, basically we would pick a boundary microphone in either an omni or a cardioid pattern. And you'd have to drill a table maybe, or things would get mounted permanently in the table. And it didn't give you much flexibility to actually choose, number one, the right type of polar pattern, or to actually aim them exactly where talkers were going to be talking so that we could have best rejection for any ambient sound. So what's unique about this 310 is that it has steerable coverage. And we can pick one of many different pattern types: omni, cardioid, supercardioid, hypercardioid, bidirectional. And we can steer that thing around the microphone. This is all happening electronically. There's no moving parts inside the device. Sometimes we get asked that question. But we can move this lobe around the mic. We can add up to 4 channels. So we've picked 4 cardioid patterns here. We've moved them all around the microphone itself in space. And by the way, there's no requirement that we have all 4 of the same type of patterns. We've got 2 bidirectionals here, 1 supercardioid and one cardioid deployed. So I think Rob will get in a little bit later to talking about how we deal with those channels coming out of the unit. But another interesting thing here is that while we could have 4 independent channels coming out for processing, we've also introduced a new-to-the-world pattern called the toroid, also fondly known as the donut pattern or the bagel pattern, depending upon whether you're East Coast or West Coast. The reality is you can see how there's the angle of acceptance really is where the talkers are, and its angle of rejection is pointed up to the ceiling, where what? That's where all the noisemakers are, right? The HVAC, the projector fan noise, etc. So this is, I want to stress, this is one output. So you're not burning up extra channels of processing, one single channel output that can cover multiple people, and it does it very well. I mentioned earlier, of course, there's wireless versions if you're not, if your customer or if your end user doesn't like the idea of drilling holes into their table. Certainly this is a MICROFLEX wireless. You're able to purchase it with boundaries that are omni or cardioid, a body pack style that, by the way, has a microphone right on board, so you can wear it lanyard style, or you can plug an headset into it, lavalier, etc. You see the goosenecks there on the left-hand side, and then even a handheld. So the form factor, you can get any kind of form you want, basically, in a wireless if you don't want to have wired mics in the table. And then finally what happens is somebody comes in and says, you know, this table, we paid a lot of money for it. We're not going to drill holes in it, and I don't want anything else on it. I want the audio to be just invisible. I don't want to see it. I just want it to work. So they say, don't put any microphones on my table, right? So then we get asked, okay, let's which Shure microphone should we hang from the ceiling? We're thinking of something like this, the MX202. And of course, we immediately say, please don't do that. Based on what we've been talking about thus far, even a supercardioid or hypercardioid microphone hung from the ceiling, that critical distance now is so far away that the voice is becoming part of the noise floor. We need something with much more rejection that any of these other ceiling products can give us, and that is the MXA910. The MXA910 can deploy up to 8 different lobes, and they're all steerable coverage. There's over 100 microphone elements in that thing that creates these steerable lobes. It gives us great pattern control, fits right into a 2x2 type ceiling tile. It can be suspended, it can be mounted in hard ceiling, multiple different mounting options there. But the idea here is that we get that stuff up off the table, yet have very directional lobes to reduce ambient noise. Here's how that steerable coverage works. We know that these lobes are narrower than any shotgun microphone. We can deploy a lobe, and they're adjustable between narrow, medium, and wide coverage. That's 35, 45, or 55 degrees. If you remember back to that cardioid pattern, you know, we're looking at like 130 degrees angle coverage, very wide on a cardioid. Even the bidirectional, which was the narrowest pattern that you could pick on that chart, That was 90 degrees coverage. We're talking 35, 45, or 55 degree coverage pattern. This is very important. We can steer that lobe around the room wherever the talkers are. So if I wanted to have complete room coverage, I'd deploy all the 8 lobes everywhere, and then no matter where anybody walked throughout the room, it would follow along with our auto mixer, and everything would be great, full coverage. Otherwise, if you have high ambient noise floor, you might want to be more precise about where you steer this thing, keeping it where the talkers are and away from where the noisemakers are. That's kind of the beauty of this mic, is that you're in control. It allows you to have full coverage in the room or very direct coverage. Here's what the lobes look like on that 910. The wide, remembering that's 55 degrees wide. The medium gets a little tighter, 45, and then the narrows down to 35. So it's great to talk about this stuff, but wouldn't hearing it in action actually work a little better? I think so. So you've been listening to me on a close talker mic. This is a Shure SM7B. This is just my standard conference room setup that I use with headphones. Tends to work really good for me. And then I have a gooseneck setup that is an MX410. It's about 18 inches away. And I'm going to switch to that now. So now you're hearing me on the MX410. This is a 10-inch gooseneck, as I had mentioned. It's about 18 inches away from my talker position. Still sounds very good, but you're probably hearing more room now on that 410. Now I'm going to switch over to a boundary microphone. This is the MXA310. Now I'm talking using the MXA310, and the MXA310 is in Omni right now. So you're probably hearing plenty of extra room coming in. And to kind of solidify that idea, I'm going to quickly switch to a supercardioid. So now you're hearing me on the MXA310 in supercardioid. I probably sound much more focused, and you hear less room even yet. I'll go back to the Omni. All right, there's my Omni microphone. And again, you're probably hearing more room. And the next one I want to show you is a standard MX202 ceiling microphone. This is an MX202 ceiling microphone hung about 6 feet away from me. I'm in a seated position. It's hung directly about 2 feet in front of me, but again, about 10 feet in the air. So it's as the crow flies, it's about 6 feet away from me directly. Now I'm going to go to the 910. And here is the 910. The 910 is also hung about 10 feet in the air, one lobe deployed facing me on a medium width lobe. And again, it's about 6 feet directly as the crow flies from me to the microphone. So, switch back to the SM7B here, kind of come back home. You might say, you know, all of those sounded quite acceptable, not too bad. My room, by the way, is no acoustical wonderland. It's got some reflections and things going on in my conference space. But what's really kind of proves the point here is when we introduce noise source. So I'm going to turn on a little HVAC noise. And you might have heard some noise come up in the background there. Again, I'm talking now on my SM7B. Now I'm going to switch over to the MX410. Now I'm talking into the MX410. This is a gooseneck mic. It's 10 inches long, about 18 inches away from me. Now I'm going to switch over to the MXA310 table array microphone. Whoop, there's my noise source. Switch over to the 310 table array microphone in Omni. All right, here we are in Omni mode on the 310. And to keep it similar here, we're going to go to a supercardioid on the 310. My 310 is now deployed with a supercardioid. Hopefully you can hear the difference between a supercardioid and a Omni on the table array. I'll go back to Omni here. Here's the Omni on the 310. And also, here's our 202. We won't stay here for long because it's not too pleasant. There's our 202 ceiling microphone. Ambient noise at nominal level, but my voice is probably covered up, pretty much buried in that noise floor, is my guess. Now we're on the 910. Here's the 910 with the same noise floor as all the rest. You probably hear better rejection. More of that noise has gone away now. So we'll round robin all the way back to the SM7. Here's that close talker SM7B sound. And you hear the attenuation of the noise, ambient noise of the room, and my voice sounds much more direct. I'm going to turn that noise off because it is kind of a little distracting after having nice and quiet conference space here. So that's kind of a round robin on how things sound. I wanted to turn this over to Rob to give us some updates on the 910.
All right. Thanks, Chris. So for those of you that may have stopped by the Shure booth at Infocom, we were showing off some new firmware for the MXA 910 and 310, which is going to be released. You'll be able to download it from the Shure software update utility this week. It should be out any day now, so check back again for that. But just wanted to give you guys a quick overview on some of the new features that's coming out for the ceiling array and the table array. So we've got this 910 right here. And the first thing I want to show you is over here, this EQ contour. So this is basically, you can think of as like various quick EQ presets where you can just choose. We have a preset high-pass filter, a low-shelf filter, or a multi-band filter, or of course you can just turn it off. So think of these as just quick little like starting places where you can tweak the sound of the microphone. And they can be used basically in addition to the channel EQ that the microphone has as well. So makes it a little easier to just quickly contour the microphone and get it sounding the way you want. One important point is that if you do update a unit that's already commissioned, all of your EQ settings or the low shelf filter will all be remembered. They'll all carry over, so you don't need to worry about that when you do the update. Another thing on the EQ side here is we have this bypass button, and this is a quick little handy button, particularly if you're using our microphone with the P300, which is our 8-channel AEC processor, because we actually recommend that when you use it with our P300, the microphone should be flat, and you should do all of your EQing in our P300 Dante processor. So with this bypass button, you can see that I have an EQ contour and I have some EQ here. That just simply turns everything off, and then you can quickly turn it back on again. So also a great way to just do quick A/B comparison to see if you like the sound of your mic if you are doing tweaking here. So that's a little bit about what's new on the EQ side. Another change that we've made is on the Automix channel. So as most of you probably know that are familiar with the 910, you can use each channel direct out via Dante, but we also have a built-in automatic mixer. That's an additional 9th channel. So we've made some changes to the automatic mixer, some new features here as well. One is we have this send to mix button. Currently on the older firmware of the 910, all of your channels always were routed to the automatic mix. Now you have the choice to actually remove a channel from the automatic mixer and basically send it as a direct out only. So this gives you a little more flexibility in your routing out of the microphone. If you want to send some signals maybe to a voice lift mix versus a record mix or to your far end, you can now have the choice to send some of the channels direct out only. Another new feature we've added is basically a second gain stage. So we now have faders on the Automix page. These are in addition to the faders that we have on the channels page. And the difference here is that these faders and meters are before the gating decision, before the automatic mixer. And here on the AutoMix page, we have the faders that are after the automatic mixing. And these are great tools to have now, because if you have a talker that maybe is a little quiet, you want to turn them up just to give them more level. If you turn up the gain before the automatic mixer, you're actually giving priority to that channel, and they're going to always gate on, maybe even if they're not talking. But now having the gain control after the mixer or post gating, you can now adjust volume levels without changing your gating decision. Another new feature for those of you that are familiar with using the automatic mix on the 910, we have this echo reduction feature, which can help to prevent echo when you're using it directly with a soft codec or a hard codec without per channel AAC in between. And we still have the same levels of echo reduction, soft, medium, and hard. But now what we've added is a fader and meter here as well. So you can actually see the level that's coming in to your echo reduction reference, and you can adjust that level right here in our software as well. So that's another new update in this 3.0 firmware that's going to be coming out. A couple other new features to point out. One is a couple updates to the LED. One, we have more brightness settings. So instead of just a regular and a dim and an off, you can now be more granular in your brightness setting of the LED. And one of my favorite features is we have a whole host of new colors you can set that LED to. So if a customer wants to use specific corporate colors, or maybe university colors, or whatever, you want to show different room statuses, you can have turquoise, gold, cyan, sky blue, all sorts of nice little colors. And of course, you can still turn off the LED as well. So I think the last new feature to show is for those of you who are familiar with using the auto position feature on the MXA 910. This is a great way to quickly move a lobe to a specific talker position when you're doing the setup and the commissioning, and then make sure it's in the right spot and tweak it from there. Anyone who's used this feature in the past knows that it can take about 20 to 30 seconds per channel to do this position. So in this new firmware, what we've done is really sped up that algorithm. So I'm going to show you visually what that looks like. Obviously, you're not listening to the 910 right now, but I'm going to go ahead and try an auto position on this channel 1 here. We'll see how long it takes to catch my voice. So I'm just going to start that here, and I'm going to keep talking, and it's listening for me. And there you could see I couldn't even get through a sentence, and it moved it to my position in the room. So that just really cuts down on the commissioning and setup time with this new faster algorithm. So that's a little bit about what's coming in the MXA 910. We have a lot. I'm going to go ahead and open up the 310 here. And we have a lot of similar features with the 310 as well. We have the bypass all EQ. We have the brightness and LED settings as well. We also have the fader on the AutoMix, which of course we're not using the AutoMix right now. But probably the biggest addition to the table array is we now have EQ on every channel. Previously, we had EQ, just a single channel of EQ, and you had a choice of where to assign it. But now you don't need to worry about that, because you can see that we have EQ on every channel, plus the auto mix out as well. So as I said, this is what we're calling our 3.0 firmware update, and check back later this week, because it should be out up on our update tool very soon.
All right, great. Thanks, Rob. And thanks, Chris, for all that great information. Before we get to the Q&A section, just a couple more notes. As I mentioned at the top of the webinar, remember you can send your... you can view this recorded version of the webinar at shure.com/training in about a week or so. If you have suggestions for future webinars or other topics you'd like to see us tackle, please send those to training_us@shure.com, and we will consider any suggestions that you might have. And the one email address that's not on here is support@shure.com. We're going to try and get to as many of the questions as we can today, but if we don't get to your question, just know that you can always send it into support@shure.com Shure.com, and one of our applications engineers will be able to answer that for you. So again, the questions pane is located in the GoToWebinar control panel. So I'm going to start going through some of these, and if you have a question that hasn't been answered yet, please feel free to type it in there. So I'm going to start with this one. Might be for Chris, but it's related to when we were talking about the noise criteria ratings. The question is the NC rating measured in Sabins?
NC rating. It's actually, that's a good question. We'll have to look that up and get back to you.
Okay.
Do you know, Gino?
I don't. I believe that's a separate number, but I couldn't say any more than that about it. So you're right. We'll look that one up. Good question. Let's see. Are Polycom and similar conference phones essentially decorative boundary microphones?
Well, my answer would be yes. Typically, the phone is on the table. It's not like there's a gooseneck or something else. These things have some type of a device that sits out. It could be external to the phone because some of them plug in externally and kind of give you the idea that you can get more microphones out on the table. My experience with most of them, though, is that they're probably omnis or cardioids, so they're very wide in pickup range.
Mm-hmm. And then remember, there's more to it than just being a microphone, because those Polycoms and the Starfish phones and those other things have tons of processing going on inside of them as well. So I guess the advantage to them is that there's no real user setup involved in terms of like you just plunk the thing down on the table and make your phone call and away you go. But the downside to that too is, again, you have no real ability to, if it doesn't sound good, to do anything about it because there's no controls or anything. It's just basically a telephone that sits on the table, for lack of a better term. So, but yeah, the principle is basically that of a boundary mic as far as the microphone itself. Let's see. What else do we got here? Well, this is an interesting question, unrelated to conferencing, but related to the MXA 910. Could it work in radio, like for live programs or other, I guess, broadcast applications? I believe we have seen that work.
Yeah. Oh, you want to go ahead, Chris? Or
No, I think the funny part is I think we all have different experiences with it. So the short answer is yes. Rob, you go ahead and tell them your experience.
Yeah, no, Chris is right. The short answer is yes. Basically the MXA 910, which was designed for conferencing, which is fundamentally just sending audio from one room into a far end. But if that far end is a broadcast feed or recording, the MXA 910 can work really well. And we've seen it used in actual real-world applications for various sporting events or broadcasts where it's actually used in the broadcast studio as, for example, like an interview mic, where instead of putting a lavalier and miking up different people being interviewed, you just put one 910, aim one lobe at the interviewer, one lobe at the interviewee, and then people can come and go, and it sounds really good. We've even seen it used in as like an ambient microphone for an actual television studio, where it's been able to go very high in the ceiling. And this gets back to kind of what Chris started out this webinar all about, is that in a broadcast studio or a room with that very low NC rating, then we've even seen it used at like 20 feet high. But of course, in a typical conference room with a higher NC reading, you wouldn't do that. But the short answer is, it can definitely be used for recording or broadcast type of application.
Here's another question that I guess is along a similar vein of maybe alternate applications for some of these microphones. Actually pitched as a webinar topic, but I think it's just kind of related here, which is audio issues. The suggestion was any plans for a webinar with audio issues with university lecture capture systems, smaller rooms and auditoriums, etc. So it would be great to eliminate the need for professors to use lavaliers. And again, I think we've seen the 910 used to essentially cover the professor or the lecture area rather than have them need to wear a microphone.
Yeah, it kind of brings up two different separate topics. One we have not covered and we don't have the time to go into, but one is the idea of voice lift, being able to get the professor's audio into the space. Certainly, a lavalier or ear set microphone is potentially the best solution for that. But we often get asked, well, can if we have the 910 there for lecture capture, can we use it also for voice lift? And the answer is it depends. There's a whole nother webinar about that. I think Gino can refer you to that. But yes, absolutely. And not only do we deploy lobes across the front for an instructor or professor to walk back and forth and have completely even discernible coverage across the front, we can also provide that data to your control system. So if you wanted to use that to, say, recall presets for camera tracking, we can tell you which lobe is being activated, and you can steer a camera around based on where the audio is. Yes, video follows audio for once. That's awesome. Yeah, and for what it's worth, there is a company who already builds a box that's kind of all ready programmed to do this. It's called One Beyond. There might be others out there. That's the one I'm familiar with. But again, this is something that's, if you got a guy who knows how to program Crestron stuff and a good camera system, this is all, you can do this on your own.
Speaking of programming, programming the mics to do things, the next question is there a function in the array mics to auto mute when program video is played? And I don't think there's a specific function in the mic that does that, but you should be able to program via like a Crestron system or something like that to make such a thing happen.
Yeah, that's right. So if you do have any kind of control system that's controlling your program video and your microphone, you can certainly have a command sent to the microphone to mute the audio, change the LED, really do whatever you want. So there are a whole host of commands that are available on our website for how to control the microphone through a control system.
Cool. Let's see. Here we go. What is the optimal distances for different microphone types, boundary especially?
Yeah, so there is a rough quote-unquote distance factor that some of these have. There's a whole other slide, I guess, that we could have talked about there, but all of this is based around your ambient noise level. So again, just to be clear, an omnidirectional microphone sounds amazing in a room with less than an NC15 rating and a low ambient noise floor. The second that starts rising, we have to get the microphone closer and closer to the talker, or have a more and more narrow view, basically, of the sound source. So that's where we get into these tighter patterns. And there, for instance, an omnidirectional mic, if you like the way it sounds at a distance of 1x, whatever that might be, keep it simple, let's just call it 1 foot, if you like the way it sounds at 1 foot. A cardioid has a distance factor of something more like along the lines of 1.7 feet away. It sounds similar acoustically. So almost 2 times the distance a cardioid mic will sound similar acoustically. The 910 ceiling microphone is really up in the 4 times that distance. So if my Omni sounds good at a distance of 1, the ceiling microphone is going to sound acoustically similar at more like 4 or 5 times that distance. If you can imagine now our Omni mic sounding good at 2 feet away, which doesn't seem like that big of a distance now for an Omni mic, I've just doubled the distance acoustically where my 910 could go. But I just want to make sure it's clear, this doesn't mean that you can put the 910, 20 feet in the air and know that it's going to sound good. You really have to you have to go back and consider the acoustic environment. Rob pointed that out earlier. If it's nice and quiet, great. No problem. I mean, I think we even have some recordings somewhere where somebody put it 50 feet away, but it was dead quiet and you could hear. So.
And I'd just like to add that, too, again, all your examples there are related to the polar pattern. So it doesn't really have as much to do with the physical design of the mic. It doesn't matter whether it's a boundary or a gooseneck or a hanging mic. It's about, is it omni? Is it cardioid? Is it the highly directional lobes of the MXA 910. It's not the physical shape; it's the actual polar pattern that dictates that distance factor. Okay, can you use more than one P300 to achieve the amount of channels needed for two MXA 910s?
Yeah, the answer is yes, you can. I would recommend that you get with your local rep. We do have a method to the madness to get those things working together. I will point out that it's also true that, for instance, some of these boardrooms that we do, if there's two 910s installed, it's rare that there's 8 lobes out of both coming out. So it might be 3 or 4 lobes on one 910 and 3 or 4 lobes on the other 910. So it's kind of 2 parts to that question, I think.
Okay, well, I believe that is all the questions. The last thing that was just typed in here was another plug for the combo of the One Beyond system with the MXA 910. So we have an attendee here who has had success with that option. We'd like to thank all of you for joining in today and listening, and for submitting your questions. Again, as I mentioned, you'll be able to find the recording of this webinar on the Shure website, www.shure.com/training, in about a week. Thanks again, and we will see you next time.